Thank you everyone for joining us today for Data Theorem's webinar series. Our topic for today will be Automate Software Security Checks for Open Source Software and SDKs. Before we jump into the topic, I just wanted to say a little bit about Data Theorem. The company was founded in 2013 in the heart of Silicon Valley, headquartered out of Palo Alto, California, with offices in both Paris and in New York. We have a very strong leadership team that individually have over 15 years of cybersecurity expertise among each of them, have published over 6 cybersecurity books, and led over 4 billion in security acquisitions. A lot of this has led to a great deal of success, which has given us the opportunity to work with some amazing customers, some of which you see here, to be a part of not only their mobile AppSec programs, but to also help them with a number of other aspects of their security. Now, before I introduce our speaker, I just wanted to say we will have time at the end of the presentation for Q&A. If you do have a question, please feel free to enter it in the Q&A panel within the event center, and we will go ahead and address it at the end. With that, I'd like to introduce Eric Castro, who will be our speaker for today. Eric?
Okay, thanks, Richard. Can you hear me okay? Can you guys hear me?
We can hear you.
Awesome. Thanks, Richard. Okay, so hi everyone. My name is Eric Castro, and I will be talking to you about security in open source software and SDKs, and more precisely about automating security checks in open source software and SDKs. All right, so yes, so our agenda for today. So we will go over things like the obvious benefits and the importance of open source and SDKs in general, but also a little bit of their often ignored and underestimated darker side. We will talk about the risks of using third-party software, and I will talk a little bit about the common limitations that developers and companies face when dealing with the security threats present in third-party software. And lastly, the most important thing that we want to share is what we consider to be the most efficient solution in dealing with those problems. And that solution is automation, automating the security of third-party SDKs and third-party open source components of our software. All right, have I been made the presenter?
Yes, you should be good.
Okay, good, okay. All right, it's working, all right. So the benefits and impact of open source software and SDKs. All right, so let's get started. Let's talk about the positive side. Why are these important? Some of the things in this section will sound very obvious to you, but it's important to point them out because we're not trying to discourage the use of open source or SDKs. They are and they will continue to be a vital part of today's software development process. So on the contrary, we're either trying to help them become more secure or at the very least protect ourselves as much as possible from the risks of using them. So SDKs, software development kits, well, of course, they help speed up app development. When you think of a certain functionality that you need, chances are that it might have already been done. So I don't have to spend time making it myself. I will be saving time, and since time is money, SDKs also reduce the overall development costs as well. And they provide high-quality solutions to well-known problems. Why reinvent the wheel? But also, these are often more reliable than any solution that we could have thought of to begin with. So why reinvent the wheel when someone else has probably made a much better wheel already? And who knows, maybe we're talking about a wheel that's been tested for years and approved by thousands of people that are using it today, right? So next, open source software. So in addition to the benefits from an SDK, if it's open source, then we also add the benefits of it being a project that is collaborative or even community driven, inviting anyone to contribute. So you know the saying, two heads or many heads are better than one. So most times a community driven effort will end up producing also really high quality solutions too. And it can be modified. We have access to the source code. So if a feature is missing or needs to act in a certain specific way, we can modify it to better suit our needs. And because of its open nature, it offers more visibility and total transparency. Anyone can verify that the code is supposed to do what it's supposed to do by getting a copy of it and building it or executing it all by themselves. So which ultimately make it a lot easier to audit, as there is no black box or the need for reverse engineering of any kind if we require to understand what it does and how it does it. So yeah, so we just look at the source code. Cool. So what is wrong with it then? It could even look like it could be even more secure than our own code, but is it really the case? Well, not always. And the security risks involved in using third-party software are not to be underestimated. So, okay, let's talk about the risks of using third-party software. Uh, okay, so we have the big problem number one, which is once the app that we're building is, well, it's when it's built, there is no longer any distinction into what's first party and third party code anymore. See, there's no separation, there is no sandbox environment in which the third party code operates. But this is not a developer's fault. It's how past and still modern programming languages are designed, which makes it easier to ignore the inner issue. Third party code will end up having the same privileges as our own code. They are able to do the same things, access the same data, all the same resources as the rest of the app. So for example, once a user has allowed the app to access things like the photos, the camera, the geolocation, contacts, the third-party code that is also present in the app, it will automatically get access to that too. And there is no easy way to prevent it. You can only pray that they're not going to do anything nasty with that data, right? Okay, so if that wasn't scary enough, then we also have a second big problem, which is more of a human problem. See, most developers don't have a security first mindset, which is why we're having this webinar in the first place. No, what I mean is that a developer will often focus, a developer is going to focus and care about functionality first, because they want to build their app fast. They will Google or they will go to GitHub and they will find the best SDK there is, or I don't know, a library that solves their specific problem easily. And they want to implement it right away, kind of blindly trusting that it's going to do it and that it's going to do it well. So they won't take the time to check each line of the source code to see what threats such code could be vulnerable to, and rightfully so. I mean, it's just not feasible to do that for every single piece of third-party code that we want to make use of. It would take ages to do that. It also takes it's going to take our focus away, and also it's not necessarily a fun thing for a developer to do. Okay, so but what risks does that leave us with? Well, it might not happen often, but yes, SDK vendors and contributors to open source have already included malicious code that developers were totally unaware of and went through long periods of time without anyone realizing. And even without a malicious end goal, when a newer version of the third-party code is released, they might have included maybe an unintentional mistake that could have introduced new vulnerabilities to our project. And this, I can tell you, this has happened countless times. So yeah, let's go over some examples. All right, so Heartbleed. You might have heard about this one. It affected so many systems, from mobile phones to personal computers to the crazy big server infrastructures powering websites, services, all sorts of everyday systems in which communications are secure through TLS. And the vulnerability originates in a very small coding bug in one of the most popular and pretty much a de facto standard cryptographic open source library that we all know as OpenSSL. And this bug went unnoticed for about 2 years until someone discovered it. And when it was announced, that was the day that one could safely say that a huge part of the internet itself became vulnerable. And the bug existed in OpenSSL's implementation of the TLS heartbeat protocol, which is basically a ping kind of message that is exchanged between the two parties to say something like, I'm still here, and keep that secure session alive. So the exploit consisted on lying about the size of a heartbeat request by sending a much shorter payload that the receiving end expects, and such payload must be included in the reply, except that when creating that response, all the space left from the size that the payload should have been was being filled out with random data coming from previously written memory space that was no longer in use. And many times it contained just garbage and unusable information, but many other times it included unencrypted data that was previously processed, potentially exposing tons of sensitive information, and which allowed attackers to exploit this infinitely and silently until they could get anything of interest to them. For example, I don't know, usernames and passwords, or anything that looked like messages, emails, anything. So to get a picture of how big of an issue this was, when the bug was announced, a fix for it was released that same day, but still 1 month later, 1.5% of all 800,000 most popular TLS-enabled websites were still vulnerable. So that meaning that during that time, anyone could have just sit at home, program a small script, and constantly send these websites maliciously crafted heartbeat requests and see how much sensitive data that server could leak. Yeah, so fun stuff. Let's see another example. Kochava. So Kochava is a company that provides developers and marketers mobile attribution and analytics tools to promote their apps. And it was discovered that releases of their official Android SDK between 2014 and 2015, those releases were disabling SSL hostname validation for the entire application instead of just the connections with the Kochava servers. And this is huge because this immediately made the entire application, vulnerable to SSL man-in-the-middle attacks, allowing anyone that could intercept the connections to use any certificate signed by any certificate authority with any hostname, giving the attacker the ability to compromise all communications since the certificate itself was not being validated by the app as it should have. And the reasons behind the SDK needing to disable such thing, they don't necessarily need to be malicious. It could have been a simple mistake, but in the end, it was something that Kochava didn't realize and kept releasing new versions of the software with such problem, leaving all of their customers' applications exposed. Great. Next, we have another example here. This is a different case. So this is a case in which a company providing an SDK for mobile advertising has intentionally embedded code that could allow to remotely control a backdoor, compromising the user's privacy or even exposing sensitive data. So the SDK would be periodically asking a server for JavaScript commands that would trigger these backdoors, allowing for a wide range of abilities like I mentioned, it could be retrieving data from the apps container, capturing audio, capturing screenshots, and so on. Now, their servers have never been observed to be pushing any of these commands during the time of the investigation, but it was stated that these could appear at any time, and any affected apps would retrieve and execute them without the user's knowledge. So, pretty scary stuff. And then I have one more example, Silver Push. This is an interesting one. How many times have we heard these stories about our phones listening to our conversations because we were getting ads about stuff that we were talking about the day before or a couple of hours before? There was this generalized paranoia about this, especially last year. And it turns out that some researchers conducted investigations ultimately stating that our phones were actually not listening to us. Or were they? Well, Silverpush uses this technology in which they are able to produce targeted ads by picking up inaudible ultrasonic signals that are purposely embedded in TV or radio adverts. And developers include their SDK in their applications for monetizing purposes and require the user to enable the microphone. So in a way, it was not specifically listening to our conversations, but instead it was using the microphone, waiting for these ultrasonic signals to help identify the ad itself and eventually track what the user was watching on TV. But here's an example where privilege separation between first and third-party code doesn't exist. What is the app required to use the microphone for its own legitimate purpose, but it was also including this SDK with it? If the user said yes to use the microphone, let's say for a dictation app, the user was also giving it access. It was also giving access to this SDK without even knowing it. But the particular problem with this tracking method was that it was collecting such information not only without the users being warned about it, but also when the application was not even in use. And of course, most developers were not even aware of that. Okay, so how do we deal with these kind of issues in third-party code? Let's take a look at a couple of the most common and legacy approaches, and let's also take a look at their limitations. Okay, so there are two big resources for known security issues found in publicly released software. One of them is the National Vulnerability Database, or NVD, which is a U.S. government hosted repository, and the CVE, the Common Vulnerabilities and Exposures Database, which is also maintained by a government contractor. The problem with relying on these two is that they are very broad. They don't provide a clear solution to fix the problem. They might not be up to date, and if their maintainer resources are limited, it might take a long time to perform a deep research on the issue and fully document it. And also, their descriptions are mostly signature-based, which could lead to false positives, as they represent a static analysis of the issue and not a dynamic analysis or runtime-based. So another classic solution, especially if a problem is critical and the fix is needed immediately, we can bring in consultants to address the problem. But this is a one-time, manual, very expensive, and slow alternative that cannot be applied easily in multiple projects, and even less in a continuous manner. It doesn't scale. Well, how about visiting developer forums and ask for a fix? Well, this leaves us to the mercy of the knowledge of someone who would be willing to help us. So kind of like, in other words, it's unreliable, it's slow, and could mean that we're also exposing such vulnerability impacting our apps to the public, which is something that we definitely don't want. Finally, one could try a kind of do-it-yourself approach and maybe have your peers review it. But unless your team has a deep understanding of the problem itself, which could easily not be the case if no one has a security background, this could take very long. It also doesn't scale, and thus it becomes an expensive and potentially unreliable approach as well. All right, so what is a better approach? Let's talk about security checks. Let's talk about automating security checks and fixing problems efficiently now. So modern software development practices require modern security solutions for today's fast-paced software release cycles. Well, Agile and DevOps have transformed release cycles in software development, progressively increasing in speed in the last, I don't know, 10 to 15 years. You know, from a new version every now and then developers it was much slower. Now developers are pushing new code multiple times a day, which is automatically validated through continuous integration, and often it's even automatically deployed. So many of these things have gotten so much easier for developers. As you know, technology advancements have allowed them to deploy an entire application scaling indefinitely in just a few quick steps, something that was not thinkable of 15 years ago. And fortunately, security has also caught up in this process of growth in speed and growth in efficiency, because today there are tools that make it possible for things like uh, introduce security earlier in the life cycle of software development, which turn a classic DevOps flow into what we know today as DevSecOps. This is done by performing automated static and dynamic analysis continuously on each release cycle. And this is key because it ensures that if something that is secure today is not secure tomorrow because of a recent change, or because of a new threat that was discovered, we can detect it quickly and take action on it immediately before it becomes a bigger issue, and that could potentially save us from much more worse things, like being, I don't know, in every news headlines because of a big problem that got discovered in our own software. But more importantly, these automated checks will scan both first-party and third-party code, including all open source components and SDKs in our release. And as I already mentioned, it is not enough to just do it statically, but also dynamically, that is at runtime. So as I was saying, being able to identify issues in third-party code at runtime is important to avoid false positives, but also open up possibilities for a much deeper analysis other than just looking at the binaries code and hope to identify vulnerability signatures present in them. So this way, we're able to look at the app's behavior in real time, and we can uncover security flaws that aren't otherwise possible to detect. Like, for example, if a secure communication is properly validating an SSL certificate or not, like the Kochava case that I just described earlier. They also guarantee to stay up to date with the latest vulnerabilities known, meaning that if a new threat is discovered tomorrow, we will be able actually we will be the first to know if we're vulnerable or not, and we will be able to act accordingly and in a timely manner. And since these tools also provide explicit recommendations and secure code examples on how to fix these issues, we can also rest assured that we will not need to spend ages trying to understand the issue first in order to come up with a solution for it. Which leads me to the last bullet point as another key advantage of this approach, which is that no security expertise is required to implement it. Okay, so let's summarize what we just discussed today. So yeah, pretty much every developer or team uses third-party open source or SDKs in one way or another. There's no question of that, and that is not going to change. It speeds up development, it reduces costs, and avoids reinventing the wheel. But remember, there are inherent risks of which might have their roots in how programming languages are designed that won't prevent such third-party code to do unexpected or even maliciously oriented things in our software, because as we discussed, they have the same level of privileges as our own code. There is no easy way to change that. But we can take measures to become much more confident about making use of such third-party code, reducing those risks to a minimum, and that is only possible with the continuous and early detection of threats, plus the ability to quickly fix them without having a deep expertise in security. And that is only possible by leveraging tools that automate these checks and integrate into our DevOps flow to transform it into a DevSecOps flow, and thus making security an integral part of our continuous integration and continuous delivery lifecycle. So whenever there's a code change, it will be validated automatically for security compliance, and when a problem is detected, recommendations that are easy to follow and also secure code examples will be provided, helping speed up the process of addressing those problems. So to finalize, this is what we believe is the best way to deal with security problems, not just in our own code, but also in all third-party code coming from SDKs and open source software. So I hope that this was useful to you, and that's pretty much all that I had to share today with you. Thanks again for joining, and I will hand it back to Richard.
Yeah, no, thank you, Eric. So real quick, we do have one question, and it is it possible to detect obfuscated dormant backdoor code in closed source SDKs before they become an issue?
Okay, good question. Well, this is kind of similar to the example that we talked about the iBackdoor SDK with a company purposely embedding a backdoor functionality that developers were not aware of until someone discovered it. Uh, so yeah, so how can we protect how can we protect from those? Well, the unfortunate answer is that there is no easy way because and this is why dynamic analysis is important because code could be present in the application, but it might never be executed until someone pushes the button, and that is not necessarily an easy task. It's not easy to detect that until it happens. So this is why this is still the best approach. The best approach is that because our security in our software project is automated and it's integrated into our software development lifecycle, at least we will have reduced the risks to the minimum, so that whenever the problem is detected, either by us or by anyone publishing the problem on the internet, at least we're going to make sure that we're going to be the first to know and that we're going to be able to fix it as quick as possible before they become a bigger issue.
Okay. Well, thank you, Eric. There are no other questions, so I'll go ahead and we can go ahead and wrap up. For anybody who would be interested to learn a little bit more about how data theorem can help with automating software security checks within your own applications to assist with open source software and SDK vulnerabilities, you can go to datatheorem.com/demo, and we'd be happy to set up some time to review that with you. I want to thank everyone again for joining us for today's webinar, and have a good day. Thank you.